Welcome to the Deep Dive. Today we're really diving into something amazing, cosmic time capsules, basically, meteorites. These aren't just any rocks. They're like fragments from the universe's own storybook falling right through our sky. And they carry these incredible tales about, how our solar system started, maybe even clues about life itself. Our mission today, to pull out the key insights from our sources on these space travelers. We'll cover their journeys, their science, and yeah, there's sometimes surprising value. What can they really tell us? And, what future could they hold?
It really is something profound, isn't it? Just the idea,
Yeah.
holding a piece of rock or metal that's journeyed for maybe millions, even billions of years through space is literally history in your hand and packed with, well, an unbelievable amount of information.
Okay, so let's start with something I think trips people up. Meteoroid, meteor, meteorite. They
Yep.
sound so alike. What's the actual difference?
Yeah, that's a great starting point. They do get mixed up a lot, but they're distinct stages. So a meteoroid, that's the object itself, just a piece of rock or metal, floating around in space. Before it gets anywhere near Earth, it's the raw thing.
Out in the void.
Right. Then when it hits our atmosphere, friction just ramps up incredibly fast. It heats up, glows, sometimes it just burns away completely. That streak of light we see, the shooting star,
Yeah.
that's the meteor. It's the event, the light show in the sky.
Ah, okay. The phenomenon.
Exactly. And then if a piece actually survives that whole fiery plunge and lands on the ground,
That's the meteorite.
that's the meteorite, the physical souvenir you can actually pick up.
Meteoroid in space. Meteor's the light show. Meteorite is the rock on the ground.
Got it.
You got it.
So if most just burn up as meteors, does that mean finding an actual meteorite is super rare? Or do they hit more often than we think? Well, they hit pretty often, actually. But most are really small, maybe pebble size or even smaller. And think about it, over 70% of Earth is water. So most splash down unseen. Or they land in deserts, Antarctica, places people aren't.
Right. Makes sense.
So while we might imagine these huge impacts, most are, pretty harmless. What's really striking, though, is when you get a public event, like Chelyabinsk back in 2013.
Oh, yeah, I remember that over Russia, right?
Exactly. That was maybe a 20-meter object, and it exploded midair, shattered windows, injured people. It was a very, very visible reminder that these things are out there, and even a small one packs a punch.
Definitely a wake-up call.
Ah,
Okay, so we know what they are, but let's get to the part that always fascinates me. The value.
right.
Why is a rock from space sometimes worth so much money?
Right, the value question. It comes down to a few key things. First off, like we just touched on, rarity. Only a tiny, tiny fraction of all the stuff flying around actually makes it to the ground as a meteorite. So any confirmed one is inherently scarce.
Okay, rarity. What else?
Second is composition. A lot of meteorites have stuff in them that's really uncommon on Earth's surface, or at least not in those concentrations. We're talking rare metals, things like iridium, platinum, even microscopic diamonds sometimes. And if you think bigger picture, the scientific value is just enormous. They're like perfectly preserved samples from the birth of the planets.
And you mentioned, I saw this in the sources, amino acids, like the building blocks of life in a rock.
Yes. That's one of the most mind-blowing aspects. Imagine a cosmic delivery service dropping off the ingredients for life.
Seriously.
Yeah, the Murchison meteorite is a famous example. It fell in Australia in 1969. Scientists found over 100 different amino acids inside it.
Wow.
And some of them aren't even types found naturally on Earth. It basically forced scientists to consider if life's ingredients might have come from space, not just originated here.
That changes everything. It's
Yeah.
actual chemical evidence from space.
Delivered right to our doorstep, essentially.
So back to the money side for a second. Are we really saying some of these could be worth more, gram for gram, than gold?
Absolutely. Gold prices go up and down, of course. But yeah, for many meteorites, especially the rarer types, the price per gram can easily be $100, maybe up to $1,000. Sometimes even more.
$1,000 a gram.
It definitely surpasses gold in many cases. It's quite staggering.
Incredible. So who's actually buying these things? Is there some kind of secret space rock market?
Not exactly secret, but definitely niche. There's a thriving meteorite market, as people call it, the main buyers. You've got serious private collectors who just love owning something literally extraterrestrial. Then you have scientific institutions, museums wanting them for display and research, universities needing samples for study.
Okay, so collectors, museums, universities.
Right. They all recognize the uniqueness, the beauty in some cases, and critically, the scientific data locked inside.
Can you give us some really high value examples? Any famous multi-million-dollar finds?
Sure. A really striking one is the Fukang meteorite, found in China. It's a type called a palisite.
Palisade, what's that?
Okay, imagine like a natural stained glass window from space. It's a stony iron meteorite where you have these beautiful, often green or yellow olivine crystals like jewels embedded in a shiny nickel iron metal matrix.
Wow, that sounds amazing.
It is visually stunning. And because the Fukan one was so large and beautiful, single slices of it have been valued in the millions. It gives us a peek into how the insides of early planets might have formed.
This slice worth millions.
Yeah, but the absolute peak, value-wise, that's lunar or Martian meteorites.
Rocks from the moon. Or Mars. How does that even happen?
Huge impacts on the moon or Mars millions of years ago blasted bits of their surface out into space. Some of that debris drifted around and eventually fell to Earth.
That's unbelievable.
They are incredibly rare. So imagine holding an actual piece of the moon or Mars. That's why their value per gram can be just astronomical.
Yeah.
Way beyond gold, way beyond even most other meteorites.
Right. Okay, so this leads to a really practical point for anyone listening. What if you find something you think is a meteorite? Let's say it lands on your property. Who actually owns it? You, the landowner.
Ah, yeah, that's where things can get really messy and legally complicated. The laws vary a lot, country to country, sometimes even state to state within a country like the U.S.
So no simple answer.
Not really. In some places, it's considered part of the land, so the landowner owns it. In others, finders keepers might apply, or maybe shared ownership. And then some countries declare meteorites as, like, national treasures, meaning they automatically belong to the state for scientific study no matter where they fell.
Wow, okay, so definitely complex.
Very. It has definitely led to some major legal battles over valuable finds.
All right, so let's say one is found, ownership is sorted. How do scientists actually study these things? What tools unlock their secrets?
They use a whole suite of sophisticated techniques, things like carbon dating, but often other radiometric dating methods to figure out how old they are. Gives us that timeline back to the early solar system. They use isotope analysis. That's like looking at the chemical fingerprints of the elements inside. It tells us where the material originally formed, maybe what kind of star it came from, its journey.
Cosmic fingerprints, I like that.
And they analyze the mineral structure right down to the atomic level, how the crystals formed, what pressures and temperatures it experienced. And these studies, they've yielded incredible discoveries, like finding water trapped inside minerals in some meteorites.
Water from space rocks.
Yep. It tells us water obviously crucial for life. As we know, it wasn't just here on Earth initially. It was likely delivered, at least partly, by asteroids and comets early on. It really changes how we think about where Earth's oceans came from.
And the amino acids we talked about.
And the amino acids, exactly.
Yeah.
Huge implications for the origin of life, how planets form, just fundamental stuff.
So thinking bigger picture again, all these rare metals, the scientific gold mines, could meteorites, or maybe even going out to asteroids, trigger some kind of new mining boom, like space mining?
That's definitely moving from sci-fi toward, well, potential reality. Asteroid mining is a really hot topic. Companies like Planetary Resources, though they face challenges, really push the idea forward, exploring the feasibility.
And what's the potential payoff?
Potentially enormous.
Yeah.
We're talking trillions of dollars worth of resources estimated to be out there, not just platinum group metals, but also rare earth elements, which are vital for our modern tech phones, batteries, all that. Stuff that's hard to get here.
Wow.
And maybe even more importantly, water. Water ice on asteroids could be harvested.
Why is water such a big deal in space?
Because you can split it into hydrogen and oxygen,
Right.
rocket fuel. And breathing air, drinking water for astronauts. It's like the oil and gas station for future space travel and settlement. It could be the key to really expanding humanity beyond Earth.
Trillions in metals, fuel for space. That's immense potential.
Absolutely. Huge economic and strategic implications for the future.
Okay, let's bring it back down to Earth for a moment. Back to you, the listener. What should you actually do if you find a weird rock and think, hey, maybe this is a meteorite? How would you even know?
Right, good question. There are a few simple field tests you can try, though none are 100% definitive. First, many meteorites, especially the common stony iron and iron types, are magnetic because of the nickel-iron content. So, does a decent magnet stick to it? That's a clue.
Okay, magnetism.
Second, they often feel surprisingly heavy for their size. They're usually denser than typical Earth rocks.
Heavier than expected. Got it.
And third, if it's a relatively fresh fall, look for a fusion crust. It's a thin, dark, often black, glassy, or eggshell-like crust on the outside.
Fusion crust from burning through the atmosphere.
Exactly. It's like the scorch mark from its entry. Sometimes it looks like a thumbprint pattern has been pressed into it, too.
Interesting. Magnetic, heavy, maybe a dark crust.
Those are good signs. But lots of Earth rocks can be magnetic or heavy, so it's not proof. So if you do suspect you found one, here's the really crucial advice. Don't break it open. Don't try to clean it aggressively.
Why not? Curiosity would be killing me.
Because you could destroy its scientific value and seriously damage its monetary value, too. That fusion crust, the internal structure, potential contaminants, it all matters.
Okay. Hands off, so what do you do?
The best thing is to contact experts. University geology departments, planetary science labs, reputable meteorite dealers or collectors. Take good photos, note exactly where you found it. They have the expertise to properly test and verify if it's genuine.
Right. Get expert confirmation.
Yes, they can guide you on the next steps, whether it's for science, sale, or, just keeping a cool space rock.
What an amazing journey we've been on today,
Maybe
from
not.
just defining these things to understanding their incredible scientific secrets and, yeah, their surprising price tags. They aren't just rocks, are they? They're pieces of history, clues to everything.
Absolutely. They provide this tangible, almost personal connection to the vastness of the cosmos, our origins within it, and maybe even where we're headed next with resources from space.
Which brings us to our final thought for you, the listener, to ponder. Knowing everything we've discussed, the sheer rarity, the immense scientific importance, the potential market value, if you genuinely stumbled upon a verified meteorite, maybe one worth millions, what would you do? Would you keep it, sell it, or donate it straight to science? Something to think about. Thanks for joining us on this deep dive into the incredible world of space rocks.